What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 9 of our MatPlotLib tutorial series. So without any further ado, let's get to it. So I'd like to mention, guys, that the first thing I'd like to show you in this video is how we have, and remember guys, this still pertains to the concept of styling, customizing your visualizations. So what I am showing you now is how we have the ability to control a line pattern and thickness. So this is what we will view currently. So it is nothing difficult. As you know, we have the ability to create all of these styles and customizations using the parameters that are built into the functions themselves. So import numpy as np. I will import matplotlib dot pyplot as plt. Next, I will just define a function here. This is a probability density function. So I don't want you guys to pay too much attention to this because this is just the equation that we are using for the graph itself. So go ahead, code this along with me. We'll do a is equals to 1 over sigma multiplied by numpy dot square root of 2 multiplied by numpy dot pi. That's the first one we have. So I see I have an error here, invalid syntax. That will probably disappear just now. Anyway, b is equals to, let's do -1 divided by 2 multiplied by sigma to the power 2. So that's good. The next and last step for this function is return a multiplied by numpy dot exponent. So again, guys, just to reinforce and reiterate the fact at this point, don't pay attention to these specific lines of code that we are typing. This is not the focus of the tutorial itself. This is just the distributions equation that we will be using. It's the function that we will be using to plot or obtain the y values for our data points. So the focus really of this is, I just wanted to mention this in this video because in the previous video as well, you'll notice we did code some mathematical stuff here, but the point is this is not the focus of this tutorial series. The focus has to do with the matplotlib itself. Focus on the matplotlib syntax only. Okay, pay attention to how we are using the parameters to kind of tweak and temper and change with the visualizations themselves. This, what we have coded here, is merely the function, okay, the equation. So that's really not that important. So why I say it's not important, because as I mentioned, right, matplotlib is often used in conjunction with plotting data sets and so on, but it's also used for mathematical modeling. Okay, statisticians and physicians and so on who deal and specialize with physics and these fields of mathematics and so on, they use matplotlib in a scientific way. Okay, so really that is where all these equations are coming from. Okay, from the sources that I am using, they've used these kind of, I would say, in inverted commas, high leveled equations just to give us the full feel of matplotlib itself. So numpy.linspace, let's do -6, 6 and 1024. Now comes the fun part. We are plotting a line graph, okay, because the whole point for this specific code cell, we're learning how to control line pattern and thickness. So that is why we will utilize line graphs. So plt.plot, let's do x, and within this I can call the probability density function. I can call x 0 and 1. That's the second parameter. Now the next one we'll do is color is equals to, I'll set this equals to K. After that, I'll do another parameter. This is the one I want you guys to pay attention to. It's called line style. So I'll set this equals to solid. Now let me copy this, paste it two more times. So play around with these values, change the second one to 0.5, the third one to 0.25. The color, leave them all as black and just change the line styles now. So I want you guys to make the second one dashed, DASHED, and I want the third one to be dash dot. So PLT dot show. So I am going to run this. You guys will see we have a plot and we have various different types and styles of lines that have been plotted. Okay, so just to make life easy for you guys, these are the arguments you can pass, right? You have solid, you have dashed, you have dotted, and you have dash dot. And if you view the documentation of plt.plot, I'm pretty sure they also tell us a few of the arguments that we can pass. So that's fine. Here, this is what you have here. These are what we can pass. The description itself, or we can pass these little ASCII, these hyphens and so on, punctuation symbols that actually also mean something. So it is very cool. So we will explore more as we go along. This is what I just wanted to show you for now. Essentially, we learned how to control line pattern and thickness of the line. So let's actually proceed to view the exact same parameter, but now on a different graph. You see, line graphs are not the only graphs that have lines in which we can control the thickness and the pattern of the line. So I'd like to demonstrate now to you how we can do the exact same tweaking with regards to line thickness and style, but on a bar plot. So let's actually do that. So import numpy as np, import MatPlotLib dot pyplot as plt. I want you guys to do n is equals to 8. Then we will do a is equals to numpy dot random. Within this we can pass n. We'll do b is equals to numpy dot random. Let's do n again. Now x is equals to numpy dot a range, and within this let's pass n. So that's that. What I'd like to do now is plt.bar, then we'll open a parenthesis. So within this parenthesis we will plot a bar plot now. So we'll do x and a, that will be the first bars that we have on this canvas. Next we'll do color is equals to 0.75. Now remember, this is gray color strings. So plt again dot bar. What I'd like to mention is we are plotting a stacked bar plot. Okay, that's what we are doing. So what I'd like to do now for height, I'd like to set this equals to a plus b, and the width itself, so I think we can leave the width as is since we did not change much there. Don't forget guys, the bottom is equals to a parameter that we learnt about in the previous videos. So color is equals to w, line style is equals to dashed. So go ahead guys, run this, and I want you guys to see and observe what we get. So essentially what I'd like to do is, before we run it, right, let's talk about it. So we have plt.bar, that's the first bar plot that will be plotted on our canvas. Therefore it will be the bars that touch the x-axis. Okay, the color of this will be a sort of a blackish color because it is closer to the color 1. Now That's the first one. The second bar plot will actually be B, okay? And it will sit on top of A because we have mentioned here as well that the bottom of this bar plot is actually A. The color of this will be a W. As you guys know, we've covered these colors in a previous video, which all stems back to W standing for white. So line style itself will be set to dashed. So what I'm saying is that the bar plot that touches the x-axis will be solid by default, and the second bar plot that's stacked on top of the first one will have a dashed line. So let's actually confirm this to make sure that it is correct. So I see I have made an error here. Let me have a look at this. Okay, guys, so what you'll notice is as I ran the script, this cell rather, I was obtaining an error, and the reason is because I actually forgot to make this x variable a capitalized X. So you'll notice we were calling this here a small lowercase x, and within this we are passing a capitalized X, which is being drawn from the previous cell. So go ahead, change this lowercase x to an uppercase X, and upon running this script you will now see what we obtained. So as you can see, we do get a bar plot, and essentially, okay, guys, and you'll see, right, despite us running the script multiple times, only one bar graph or bar plot is showing on the canvas. But now, this is actually because the color we've set for the line itself, or for the bars themselves, have been set to a color of white. So if I change this to black, what you will observe is actually very fascinating. So have a look at this, guys. So this is really cool. Okay, essentially we've got our first bar plot, which is touching the x-axis, and then we have the second bar plot, which is being stacked on top of the first. So really, guys, this is super cool and interesting. I hope you guys find this as interesting as I do. Now, I think there is one more important, parameter that you guys should know of, and this will allow us to control the thickness of the line itself. Okay, for this, just to give you a bit of insight, we'll utilize the line width parameter. Okay, again, now let's go ahead, let's define some function or equation that we can use, but to save time, I'd like to utilize what we've coded earlier on. So go ahead, copy that piece of code and paste it in our new cell. Now, what we will do is essentially I will just set up my x values here. So x is equals to numpy.linspace. You guys can do again a negative 6 1024. Now for I in range 64, samples is equals to numpy.random.standard normal, and within this parenthesis we may pass 50. We'll do mu comma sigma is equals to numpy.mean samples comma numpy.standard deviation samples. Next we'll do plt.plot x pdf, and within this we'll pass x, mu, and sigma. For the color of this plot, we'll set it equals to 0.75. That's a gray color string. Line width can be set to a value of 0.5. So what I'd like you guys to do now is plt.plot. This is outside the for loop. We'll do x comma pdf. Within this we pass x 0 1. Color is equals to, let's do a yellow, and here we do line width is equals to, let's do 3. plt.show. Go ahead, guys, run the script and view the output. As we can see, essentially what's happening is that we are getting 64, well, 65 technically, because the for loop is plotting 64 line plots on this canvas. They are probability density plots, and then we have this final graph that's being plotted in a yellow color with a thickness of 3, which as you can see stands out on the canvas. So that's what the line width parameter will do. It is very interesting. You guys can go ahead, tweak it, change it, play around with it, go crazy, guys. This is fun stuff. So what I'd like to show you now, right, is another interesting concept or technique, and it's basically known as fill patterns. Okay, so you guys know, right, how bar plots, the bars of a bar plot normally are filled with the color white, okay? There's white space, but now we'll have the ability to actually add patterns to the bars themselves, okay? This will really make the bars stand out to us, especially if, you are working with several stacked bar charts or so on. Having some sort of shading or patterns inside the bars will help us to distinguish between the different data that we are working with. So what I'd like you guys to do is import numpy as np, import matplotlib dot pyplot as plt. Now same story, guys, we need to generate the data, so let's do n is equals to 8. Next we'll do a is equals to numpy dot random. We'll do n. After this, please go ahead and type b is equals to numpy dot random. Pass in n. We'll set up x to be equals to numpy dot a range of n. Okay, guys, now we may proceed to do plt dot, and remember, guys, we are plotting a stacked bar plot. So x comma a color is equals to, so remember, guys, the color parameter controls the color of the bar itself, okay? The color that the bar is filled with. And since we are going to have a pattern that is drawn inside this bar, let us not set it equals to a color that is, going to kind of overpower the pattern itself, because the pattern will be drawn with a thin black line. Okay, that's how it will be drawn. So if we set the color to be equals to, black, then it's kind of going to render the pattern inside the bar redundant. So let's keep it simple. Let's maybe do a blue. That may be good. So color is equals to b. This is the parameter I want you guys to pay attention to. It is called hatch. Hatch. Now go ahead, set this to a value of x. So I'll type the name of the parameter there. Now that's the first bar plot that we have. Now I'd like you to go ahead, plot the second bar plot. Let's do a plus b. Bottom is equals to b or a. Next, go ahead, type color is equals to, maybe for this one we can do a yellow. I would like you guys to have this parameter again, hatch is equals to, and a forward slash plt dot show. Now go ahead, guys, run this and you will observe a really very cool bar plot that shows up on our screen. So this is us having the ability to actually add fill patterns to the bars of a bar plot. Okay, so if you are wondering what are the other arguments that the hatch parameter can take, I will just put a few of them up on the screen for us or for you, so you know that you can experiment with these. They are all really just punctuation marks. So we have a forward slash, which we tried. We have a backslash. You've got a pipe symbol, a hyphen, the plus sign. You have an X. You also have an O. You've got a capital O. You got a full stop, and you have an asterisk. So you guys can actually mess around with these parameters just to see the effect that it has. So as you can see, it does indeed change. Let's try the asterisk. That may be an interesting one, and indeed it is really very cool. So go ahead, guys, play around with that and familiarize yourself with the hatch parameter. So that's all I'd like to do in this video. This video is, plus minus 24 minutes or so. So we will end the video here, guys. Thanks so much for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.